Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at the PSSA big ideas on solving equations and inequalities. So this is a review of how you've already learned how to solve algebraic inequalities using inverse operations from earlier in the school year. So quick refresher, to solve an equation means to find out what the variable should equal that makes the equation true. It also means to get the variable by itself. So how do we do that? We ask in our head what's happening to the variable, and then based on whatever's happening to it, we will do the inverse of that. The inverse of addition is subtraction. The inverse of multiplication is division. So we will do the inverse of whatever's happening to the variable. We'll do it underneath on both sides of the equation. Now, if there's two or more things happening to the variable, then we're not going to do the order of PEMDAS, the order of operations, because the word inverse means to do the opposite. So we're going to do the opposite order of PEMDAS, which does humorously spell the acronym SADMEP. But all that really means is that you would subtract or add first and then divide or multiply second. And then if there were exponents, you would deal with that third. And if there was parentheses, you could deal with that last. Although I will show you on the fourth example here that in a lot of the parentheses problems, the distributive property could be used instead and then later do inverse operations. So on this first example, n plus 13, what's happening to the variable? It's being added by 13, so we subtract by 13 on both sides. Now, we might make subtraction adding the opposite if we're not using a calculator to help us get the answer. 3n means 3 times n, so the inverse is to divide by 3 on both sides. On the next one, we have two things happening to the variable. We will follow the order of SADMEP. We will subtract or add first, so the inverse of subtracting 29 is adding 29. We do that to both sides. Then later, the inverse of multiplying by 5 is to divide by 5. We do it on both sides to get our answer. Now, the fourth example here, we have a multiplier sitting outside of parentheses. What we will do is we will distribute it to both terms inside of the parentheses. This is the kind of situation where we can use the distributive property. Once we do that, the parentheses are gone. And then we can do our inverse operations in the order of SADMEP, inverse of adding 48, subtracting 48, inverse of multiplying 8, dividing 8. So that's a quick review on inverse operations to solve equations. You can also use those skills to solve algebraic inequalities. Speaking of inequalities, a quick review over here on the right-hand side of your 4 inequality symbols. There's actually a fifth one called the not equal to symbol, which is an equal sign with a slash through it. We didn't really focus on that symbol at the 7th grade math pre-algebra level, so I didn't include that on this list. But this is just a quick vocabulary review of the greater than symbol, the less than symbol. Remember, the less than symbol is the one that looks like an L. So if you're the kind of kid who honestly gets mixed up between which symbol is greater than or less than, remember, the less than symbol looks like an L, just rotated a little bit. So that's a nice, real easy way, because less than starts with L, of remembering which symbol is which. If there's a bar underneath it, then it means greater than or equal to, or less than or equal to. And there are other real life phrases that end up meaning greater than or equal to, or less than or equal to, such as the phrase is at least. That means that's the least you could have, which means it's greater than it or equal to it. The phrase is at most means that's the most you could have, which means you could have less than it or you could have equal to it. So there are many different phrases that can mean these inequality symbols. Underneath, I have a quick review on how to graph inequalities. You will notice that if there is an equal to bar on the inequality symbol, then we will fill in the dot. The filled in dot means it can equal. If it does not have the equal to bar, then we leave it an open circle to show that it's not allowed to equal the starting number. If the variable is greater than the number, the greater numbers will be on the right, so you'll shade to the right. But if the variable is smaller than the number, less than 16, then the smaller numbers, the numbers that are less than 16, would be on the left, such as 15 or 14. And so you would shade to the left. Now, what about word problems? A lot of kids don't like word problems. So here's what I tried to teach you earlier this year. The unknown in the problem, which is often what the problem asks you to find, that is going to end up being your variable, your letter that you pick to represent that unknown number. And the trick is this. The way that math works in real life is the same way that it should be set up algebraically in your equation or inequality. Now, you might be like, Mr. Underkoffler, what do you mean? Okay, let me show you an example. We'll start with a non-algebraic example. An example like elementary school. You bought 4 t-shirts, each for $12, and you bought a $20 sweatshirt. Find the total amount that you're spending. Well, no big deal. If the 4 t-shirts are each for $12, then you would take 4 times 12. That's commonly what you do with the word each. You tend to multiply. But you're also buying a $20 sweatshirt, so that has to be added in to the total as well. Then you would multiply first, get 48, add the 20, and that gives you the total amount as your final answer. Well, how does this apply to algebra? Well, take a look. Joe bought some t-shirts, each for $12, and a $20 sweatshirt. He spent a total of $68. How many t-shirts did he buy? This is a really similar problem to the one on the left, but there's a big difference. It says he bought some t-shirts. It doesn't tell you how many. So we're going to let T represent the unknown number of t-shirts that Joe is buying. But again, they're each for $12. Do you remember how we took 12 times 4 when there were 4 t-shirts? Well, then over here, we're going to take 12 times T. It's the same idea. It's the same way that the math works in real life when there wasn't any algebra involved. So please do not think that algebra is brand new math. It's not. It's the same kind of math that you had in elementary school, except now there's something that used to be a known number that now is an unknown number. We used to know it was 4 t-shirts, so we did 12 times 4. Now we don't know how many t-shirts, so it's 12 times T. Then we're still buying the $20 sweatshirt, so that has to be added on, just like it was on the problem on the left. This time we are given the total. So it equals the total. Hopefully that makes sense to you. Then you would use inverse operations on both sides to solve, just like I was showing you higher up on this review sheet. All right, let's take a look at some problems. And you're going to try these on your own based on what we just reviewed about equations and inequalities and how to solve them. A group of adults and students buy tickets for a dance performance. Each ticket costs $4.65. The total cost of the tickets for the group is $93. There are exactly 3 adults in the group. What is the number of students in the group? I would like to suggest that you set up an algebraic equation. And if you're not sure how you would do that, let me get you started. It says that each ticket cost $4.65. So naturally, we're going to be multiplying that to the number of tickets we buy. We do know that there are 3 adults. So that would be 3 times 4.65. But there's also some students, and we do not know the number of students that are coming to our group. So we should probably pick a variable. Maybe N, maybe S. Be careful with S. Sometimes S looks like a 5. Finally, we do know the total. We know the total cost of all the tickets is $93. If you recall from the example I was just showing you, on a lot of problems, the total ends up being next to an equal sign, and that's going to hold true on this problem as well. So here's how I would recommend starting. $4.65 is the cost of each ticket. We know there's 3 adults, so take 3 times $4.65. But we also have students coming. We don't know how many, so take your variable. I picked S. Maybe you want to pick N. Take that times $4.65 as well. Add in between, and that's going to equal the total. Now, I would recommend doing $4.65 times the 3 adults to get $19.65. And now you have an equation that looks like the ones that I was showing you earlier, where there's 2 things happening to the variable that I believe that you will know how to solve. So, now that we have the equation set up, hopefully you wrote it down, hit pause on the video, solve this equation using inverse operations, and you will be able to find out which answer is correct. So hit pause on the video, do that now, then hit play when you're ready to see how you did. Okay, I hope you've already solved this on your own. Hopefully you subtracted by 19.65 on both sides. That's going to give you $79.05. Then you will divide, because the inverse of multiplication is division, and that will give you 17 tickets, and we can see that would be choice A as our answer. All right. I am not going to lead you on this problem at all. You're going to have to do this on your own. So read this problem to yourself, hit pause on the video, do the work. Again, I would suggest either an algebraic equation or possibly an algebraic inequality, and then figure out which answer choice, this time shown as graphs, would be the correct one based on your work. Hit pause, do it now, then hit play when you're ready to see how you did. All right. Let's see how you did. Now, I hope you noticed that it said that the total this time is less than $14. Less than literally means the less than symbol. Did you have a less than symbol? $5.25 for the basket. That's getting added on. Added on to what? To the grapes. We're spending $1.75 per pound. So you should have taken $1.75. We don't know the number of pounds, so I made that my variable. All right, from here, I would have subtracted by 525 on both sides. That gives me the 1.275p on the left side remaining. Oh, I accidentally have a typo here, don't I? Whoa, Underkoffler, this should not be an equal sign. This should be a less than symbol. And then $8.75. Divide by 1.75 on both sides. Oh, now I do have a less than symbol again. Underkoffler making mistakes, always fun. That's going to give you P is less than 5 pounds of grapes. Which graph is showing less than 5? Well, it was choice B. It starts at 5 with an open circle. Remember, when the inequality symbol does not have the equal to bar under it, we leave it an open circle. And if it's less than 5, then it's going to the left of 5. That's where the smaller numbers are. So, choice B is correct. All right, next problem. A quadrilateral is shown below. What values of x and y make the quadrilateral a parallelogram? Hit pause on the video. Try this on your own. If you are stuck, here's a hint. Sides of a parallelogram must be congruent to each other, which means the side that is 2x or 2 times x plus 18 is congruent to 60. The side that is 2/3 y plus 21 is congruent to 25.2. When I say congruent, I mean equal measures. Are you getting the hint? You're going to set up 2 equations. Hopefully that was the hint that you needed. Hit pause if you didn't already finish this already. Then hit play when you're ready to see how you did. Okay, I hope you've already done this on your own. You set up the equation 2 times in parentheses x plus 18 equals 60. And you set up the equation 2/3 y plus 21 equals 25.2. I would use the distributive property with the parentheses equation. 2 times x is 2x. 2 times 18 is 36. Then I subtract away 36 on both sides. Divide by 2. And you will get the answer of x equals 12. For the equation with the fraction, you would subtract by 21 on both sides. That gives you 4.2. Divide by 2/3. You may use your calculator for this. 4.2 divided by 2/3. Now, if you don't use a calculator, maybe you make 4 2/3 become 4 2/10 or 4 1/5. Make it an improper fraction. Maybe you do the rule of dividing by fractions where you multiply by the reciprocal, where you multiply by 3/2. That's an alternate way of doing the work. And either way, you're going to get the answer of 6.3 or 6 3/10 if you have it a mixed number with the fraction. So, which answer is correct? Well, I hope you can see it is definitely choice A. And I got one more for you. This one is not going to involve any solving, as you will see from the multiple choices, but it will involve some reading and interpreting. So read this problem to yourself. Try this on your own. Hit pause on the video. Try this on your own. Then hit play when you're ready to see how you did. All right. something I would definitely want to point out is that the number of small tables is called X. The number of large tables is called Y. So one thing right away I'm going to do is I'm going to remind myself that when it says each small table costs $24, we're talking about the X's. When it says each large table costs $52, we're talking about the Y's. And if you look here at the answer choices, you will see 34 and 52 being multiplied to an X or a Y. But take a look at how choice C and choice D accidentally have the 52 multiplied to the X and the 34 multiplied to the Y. As you can now see, that is totally wrong. The small tables, which are the X's, they have $34 each. So the 34 should be multiplied to the X. The 52 should be multiplied to the Y. So choice C is no good. Choice D is no good. We can eliminate those right away. So that leaves us with choice A and choice B. And they almost look identical. But choice B's second inequality is just a little bit different, and quite noticeably different. It says it is greater than 50. The choice A version of it says less than 50. Well, which should it be? The fourth bullet point up here, so the principal buys fewer than 50 tables. Fewer than means less than. So we need to have less than 50 tables. And that is shown in choice A, because that's the less than symbol with the 50, not choice B. So choice A it is. Oh, by the way, it also said less than 3,500, but all four choices said less than 3,500. So I didn't really have to even think about that third bullet point a whole lot. It wasn't as big of a factor in helping us to eliminate which choices are right and wrong. But there you go. Thanks for watching this video. This concludes the review on solving equations and inequalities, and also graphing, and also word problems. Thank you for watching. We'll see you next time.